In this video, we are going to start talking about how to evaluate trig functions and looking at angles in a coordinate plane. So when we're talking about angles here, you really haven't put this language to the angles of having an initial side and a terminal side. It just means the one that you start to the one that you end when you're measuring. So in the coordinate system, when we start putting angles in here, because previously to like with geometry, you've really only gone up to 360 degrees for a circle, but you haven't gotten past that. Well, now when we start situating them in standard position on a coordinate plane, we're going to be able to get positive and negative angles, and we're going to be able to get above 360. So above 360, below 0 with negative angles. So we always start them on the positive x-axis. So you'll see this blue angle here, okay, which I'm just going to call alpha. This is going up from the positive x-axis or counterclockwise. That's a positive angle. So maybe this alpha is like 60 degrees, okay, up from standard position. Then the red angle, okay, you could measure it around this way, okay, going up and around, or you can measure it down. Okay, so I'm going to measure this one down. We're going to call this one beta. So this one going down is going to be a negative angle, maybe negative 150 degrees. So now this, you could keep going in a coordinate plane and drawing an angle that was larger than 360 just by doing an extra rotation. So you could just go around. So this would be 360 degrees. And then to here would be 420 degrees, another 60 degrees, right? So the blue angle is 60. This green angle going around is at 420 degrees, okay? They end in the same spot, okay? You could also go backwards and get multiple different angles. What these are called is coterminal angles. They're angles that have the same initial and terminal sides in the coordinate plane, meaning they start at the positive x-axis, they end at the same spot, but they have a different measure due to rotating, okay? And one rotation in degrees is 360, one rotation in radians is 2 pi. So as long as you're adding a full rotation, you're going to end where you started. So like if we drew this red angle again, okay, or this red angle, let's say it's 50 degrees. Okay, so that's one that starts at the positive x-axis and goes to here. And then you could do multiple rotations here. So I could be going around once, going around twice, and ending here. Okay, so 2 times around is going to be 720, 360 plus 360, and then another 50 degrees. So this one could also be at 770, would end in the same spot. Again, you could also be going backwards to end up at it, but those are called coterminal angles. So you would take your angle, 50, and then add or subtract rotations of 360 as many times as you wanted. So I did twice in this case. You could do 4, 5, 1, 82, whatever you want. If you're in radians, then you're going to be adding 2 pi n, okay? So 2 pi in radians is a full rotation. So for a 30 degree angle, okay, again, so if we're just going to list some, you could just start adding 360. So over here, I'm just going to add rotations of 360. So 30 plus 360 is 390. So 390 degrees would end in the same spot. You could add 360 again, and you'd get to 750. You could add 360 again, and you could get to 1,110 degrees. All of these are going to end in the same spot. You could also subtract 360. Okay, so you could take 30 and subtract 360, and a negative 330 degree angle would be coterminal. You could subtract 360 again and get to negative 690. You could do it again. Okay, and so on, to get all sorts of coterminal angles to 30 that are going to end in the same spot. So now when we work with radians, again, this is going to be adding and subtracting 2 pi. But now we're in fractions. Okay, so in order to add fractions, you need a common denominator. So instead of thinking of it as 2 pi, I'd like to think of it in thirds. So you're going to need to convert this to thirds, which is multiplying by 3 over 3, which would be 6 pi over 3. Okay, so we're going to add 6 pi over 3. Which 6 divided by 3 is 2, right? So this is really 2 pi, but we're going to be adding 6 pi over 3 so that we have common denominators. So I'm going to add 6 pi over 3 here. So I'm going to add the tops. So that's going to be 8 pi over 3 would be a coterminal angle. Add 6 pi over 3 again. So 8 plus 6, add the tops because the bottoms are the same. So 14 pi over 3 would be another coterminal angle. Add 6 pi over 3 again, 20 pi over 3. Okay, so you're just adding rotations of 2 pi, just having a common denominator there. And then some more if you subtracted 2 pi. So subtract 6 pi over 3. So 2 pi minus 6 pi is negative 4 pi over 3. Subtract 6 pi over 3 again to get negative 10 pi over 3 as many times as you wanted. Okay, to get coterminal angles. So all of these are going to end at the same spot on the coordinate plane. Then when we're working with these angles on a coordinate plane and starting to develop or starting to evaluate trig functions, what's called a reference triangle or a reference angle is going to become a very big idea. So a reference triangle is a triangle that's formed by the terminal side, so the ending side of your angle, and a perpendicular line dropped to the x-axis. So I've drawn 4 different examples of this in each of the different quadrants. And so when you look at this, so this here's the terminal side of the angle, right? And so we're just going to drop a perpendicular line down to the x-axis. So in the first quadrant, the reference triangle matches kind of the angle created. This angle would be the reference angle, and you've got the reference triangle. When we get into the second quadrant, so an angle that's between 90 and 180 degrees, so here's the terminal side, dropping a perpendicular to the x-axis, okay, gives you a reference triangle here in the second quadrant, and this is your reference angle. Okay, so this angle would maybe be like 120 degrees. So then this reference angle here, okay, remember this is 180. So this reference angle here would be 60 degrees. This green one here is in the third quadrant. Okay, so this one is maybe, let's say it's like, I don't know, 240 degrees or something like that. Okay, because remember this is 180 degrees and this would be 270 degrees. So this one goes around. So again, draw a perpendicular to the x-axis. So this one is going to be here. Okay, let me use a segment instead so that it's actually straight. Okay, so this one here would be your reference triangle, would then be here in the third quadrant. So now remember, when you're getting the reference angle, it's the angle formed with the x-axis and the terminal side, okay? So in that triangle, the one at the origin is your reference angle. So in this case, this went all the way around to 240. So how big is this angle? The difference between 180 and 240. So this one is a 60-degree reference angle. Fourth quadrant over here, so maybe this angle right here is 315 degrees. So then this one, okay, draw the reference triangle, again is going to be formed by the terminal side and a perpendicular line drawn to the x-axis. So it's never connected to the y-axis, always connected to the x-axis. Then your reference angle, again, is right here. Okay, so you have a couple ways you could figure this one out. Okay, this one is 270. So you could go, how far is it from 270 to 315? Okay, also this one you know is 360. So you could say what's the difference between 360 and 315? Okay, either way you can figure those out in each quadrant. So 270 to 315 is 45 degrees. So this angle right here is 45, whoops, sorry, that's wrong. I mean, that's right, but that's the wrong way to think about it because you want to do 360 to 315. It just happens to be the same in this case. So this angle right here, you want, so 360 minus 315. So let me show you because I said that wrong. So if that wasn't a 45-degree angle, it would have been different. So if this angle had been here, and let's say that this is 330, okay, so then this is 360. This angle here is going to be 30 degrees. Not looking at it from 270 to there, because that's going to be 60 degrees, which is this angle, which is not the reference angle. Okay, so you want to do this one, which was the difference between 360 and 330, or 360 and 315 in this case. All right, so let's draw this, and then let's label these reference triangles. So 120, so again, when we're looking in degrees, then you want to remember that this is 0 degrees, 90, 180, and 270. So then thinking about where 120 is, that's going to be in the second quadrant. And so here, and so if you draw this, let me do a segment again that looks nicer. Okay, so you've got, you know, this whole 120-degree angle is there. Draw the reference triangle. Okay, so the reference triangle is going to connect it to the x-axis. Okay, so connect this perpendicular down to the x-axis. So here's your reference triangle right here. So you need to have your reference angle labeled. So remember, this was 120 degrees to get here. So this is, how far is it from 120 to 180 for this angle right here? So that's a 60-degree angle. That's one of your nice angles, okay, from special right triangles. So this right here is 60. So then label the sides, okay? Well, across from a 60 and a 30, 60, 90 is square root 3. Across from the 30 is a 1, and the hypotenuse is a 2. 7 pi over 6, okay? So this would be 0. Okay, this is pi, but when we're in sixths, instead of thinking it as 1, I would think of it as 6 pi over 6, so that you have a denominator of a 6. Okay, so 6 pi over 6, so 7 pi over 6 would be in the next quadrant. It would be 1 pi over 6 past this. Okay, so 7 pi over 6 would be right here. So then this reference angle, so if this is 7 pi over 6, the reference angle is pi over 6. 1 pi over 6 past 6 pi over 6. So then label the sides here. So pi over 6 is the same as a 30-degree angle. So this is going to be 1. This is going to be square root 3 across from the pi over 3 angle, and then 2 on the hypotenuse. 17 pi over 4. Okay, this one is much larger than 2 pi. So remember that this would be 0 pi, which I'm going to call 4 pi over 4 since we're in fourths. So then this would be 8 pi over 4, the same as 2 pi. Okay, so what I would do with this is subtract off rotations of 2 pi until you get on this coordinate plane from 0 to 2 pi. So I would subtract a rotation of 8 pi over 4 off of here, which would give you 9 pi over 4, which is still bigger than 2 pi, so I would subtract another 8 pi over 4 off, and that would give you pi over 4. So this is the same as a pi over 4 angle, which is in the first quadrant. You can also go 8 pi, 16 pi, 17 pi over 4 and draw it. Okay, important thing is that you know that it ends in this first quadrant, and this angle right here is a pi over 4 angle. So then label these sides. So on a 45, which this is a 45-degree angle, same as a 45-degree angle. So across from that would be a 1, 1, square root 2. So now one thing that I do want to talk about here, which I didn't because I just labeled them based on the special right triangles, is once we're in a coordinate plane, okay, now these actually represent, the sides of the triangle actually represent x and y coordinates. So this, when it's in the second quadrant, this is actually a -1. Just like if you were plotting points and I asked you, to plot this ordered pair right here, this would be the ordered pair like -3, 2 or something like that. Okay, so the x coordinate is -1, the y coordinate is square root 3. So on this second one here, okay, so again, here's the origin. So this would be negative square root 3. This would be -1. And the hypotenuse is always positive every single time. And then this one would be 1, 1, because it's in the first quadrant. So +1, +1. So just remember to put your negatives on there as well. Okay, so then let's take a look at evaluating the sine, cosine, tangent, and their reciprocals. So when we're talking about this, so here's an angle, so now outside of the first quadrant that you're used to. Okay, so we would have, if I was going to draw in this one, so we'd have the reference triangle here. Okay, and when you're doing trig, the trig is always the same as this reference angle. So you use the reference angle to help you. Okay, so here's the reference angle. Now, when we have this reference angle on the on the coordinate system, so across from the angle, this is the y value. Okay, in a coordinate system, the vertical is a y value. Next to it is the x. Okay, this is the x coordinate. And then we're going to call the hypotenuse actually an r for radius when we get into the unit circle. Okay, so now instead of saying sine is opposite over hypotenuse, when we're in the coordinate system, the opposite is always going to be the y value and the hypotenuse is always going to be the radius. Cosine, okay, next to this theta is always going to be the x coordinate. Hypotenuse is r. Tangent, the opposite is always y. The adjacent is x. Okay, opposite, adjacent. So then reciprocal functions, just flip those over and you'll have them. So now you're going to end up with positives and negatives in here depending on where this is at in the quadrant, which quadrant it's in. So in this case, this would have been a negative x and a positive y in the second quadrant. So then let's take a look at actually evaluating. So sine of 330. Okay, so again, this is 0 degrees. This is 90 degrees, 180 degrees, 270 degrees. So 330 is going to be in that fourth quadrant. Okay, so 330 is going to be in this fourth quadrant. So I'm going to draw the angle and I'm going to draw the reciprocal or the reference triangle. Okay, so then if this is 330 degrees, this is also 360 degrees, one full rotation. Okay, so the reference angle, 330 to 360, this reference angle here is 30 degrees. Okay, so that's a 30, 60, 90 triangle. Across from the 30 is a 1. In this case, a -1 because it's down. Okay, next to it, or across from this 60 degrees is a square root 3, and the radius is 2. So this is a positive x, negative y. So positive square root 3, -1. So then when we do the sine of that, so sine is the opposite or the y value, -1, over the hypotenuse or the r value, so -1/2. So opposite is -1, hypotenuse is 2. Then 5 pi over 6. So when we're doing radians, again, when I label this, then I'm going to be doing 0 radians here. This is pi radians, okay? I want it in sixths. So 1 as sixths is 6 over 6 because 6 divided by 6 is 1. So then 5 pi over 6 is 1 pi over 6 before that. Okay, so this is 6 pi over 6, so this is 5 pi over 6, meaning that this reference angle is a pi over 6 reference angle. That's the same as 30 degrees, so a 30, 60, 90 again. So across from that is a 1. Across from the bigger angle is a square root 3, and then the hypotenuse is 2. So then remember your negatives. So this is a negative x in the second quadrant, a positive y, and the hypotenuse is always positive. So there's our labeled triangle. That's going to give us our cotangent, okay? That's going to help us evaluate the cotangent. So remember, tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. Okay, so adjacent is negative square root 3. Opposite is 1. So just negative square root 3. Two more. So cosine of 225. So again, we have 0 degrees here, 180 degrees here, 220, and then this is 270, so it's going to be between there. So 180 to 225 is going to be a 45 degree reference angle because it's 45 degrees past 180. So to get to that 225, we would need 45 degrees more. So this is a 45 degree angle. Then you can label the sides. So 1, 1 for the legs and a 45 degree, 45, 45, 90, and hypotenuse is square root 2. Again, label the negatives. So this is a negative x value and a negative y value. Cosine is going to be adjacent over hypotenuse. So the adjacent to here is negative 1. Hypotenuse is square root 2. Rationalize this. You would multiply by root 2 over root 2. So this will be negative root 2 on top. Root 4, which is a plain 2 on bottom. Evaluating sine. Okay, so 5 pi over 3. So again, when I label the axis, I'm going to put this as 0 radians. Remember, this is pi in thirds. That's going to be 3 pi over 3 because 3 pi divided by 3 is 1 pi. So 5 pi over 3, okay? I would also write this one, okay, so as 6 pi over 3 so that you know, and that's 2 pi because 6 divided by 3 is 2. So 5 pi over 3 is 1 pi over 3 before that, okay? So 5 pi over 3 is going to be here. And pi over 3 is like a 60 degree angle, so it's kind of a big one. Okay, so then that's 1 pi over 3 for a reference angle. So if this was, again, 5 pi over 3 to get all the way to there, then another pi over 3 would finish it off for that whole 2 pi rotation. So the reference angle is pi over 3. That's the big angle, so across from that is square root 3. I don't really have room here. Let me move this if I can. For the reference angle. Okay, so then this would be the 1. Because this is like the 60 degree angle across from that square root 3. This is the 30 degree angle is a 1. Hypotenuse is 2. Add the negative, so this is positive 1, negative root 3. Sine is opposite, which is negative root 3, over hypotenuse, which is 2.